Okay, we're now for case 3 of solving right triangles. In this case, we have of course we know the right angle, of course, as we always know, and then we know the size of another angle and the side adjacent to that, the leg adjacent to that. So we're going to say we know angle B right here, and then the one adjacent to it would be A. So we know A, B, and C. So notice this is an example of angle, side, angle case. Okay, angle and adjacent side, the adjacent leg. Okay, well, if we know one angle, the easiest thing to do is find the other angle. It's just 90 degrees minus the one we know, so 90 degrees minus 38 degrees leaves 52 degrees for angle A. So that's pretty easy. Now, let's think about finding some sides. Notice that relative to angle B, what we know is the adjacent side. So suppose we want to find, say, the opposite side, opposite and adjacent, that should suggest tangent to you. Tangent of angle B is opposite over adjacent, that's B over A. So if we solve this for B, we just multiply both sides by A, we get B as A times the tangent of angle B. Plug in our values of A is 5 centimeters and B is 38 degrees, and we can get our answer here. So let's do this on the calculator. First of all, check your mode. I'm in degree mode, so I don't have to type the degree symbols. So I just need 5 times the tangent of 38, and that will give me B. In fact, let me just store it as alpha B in case I need to use it again later. So B will be angle B, lowercase b, 3.906, etc. centimeters. Okay, similarly, if we want to find C, we're looking for the hypotenuse, and we're given originally the adjacent side, that would suggest cosine. Now notice we could use side B that we just computed, but we would have to type in all these or use our stored value for B. It's better if you go back to the original values that you're given. So we'd like to try to make use of A and the angle B to help us find C. And of course then the cosine of angle B is adjacent over hypotenuse, that's A over C. Okay, solving for A is C times cosine of B. Actually, we want to solve for C. So we'll multiply both sides by C, and then we'll divide both sides by cosine of B. So C is side A divided by the cosine of angle B. Plug in our numbers, 5 for A and 38 degrees for C, and we can get an answer there. And this one should be correct, but let's check it out. That's 5 divided by the cosine of angle 38. So notice solving these triangles does involve a little bit of algebra skills, but not too much here for this case. Just a simple solving this equation for that C in the denominator. Finally, we want to find the area. Remember, the area is just 1/2 A times B. Here I am going to refer back to my answer that I used earlier, but I am going to refer back to B that I have stored so I can get all those digits, so I don't round off any until the end. So that's very important. 1/2 times A, which was 5, times B, which I had stored as alpha B, and so this gives me my answer. Now round off if you want to some appropriate place, but don't round off in the middle of a calculation. So that's how you work one like that, where you're given the hypotenuse and the leg. I'm sorry, that's wrong. This is the case where we have an angle and an adjacent leg. Okay, let's give it a different one. Let's say we have a side length of, let's say 11 and then a 20 degrees for angle B. So A is 11 centimeters, B is 20 degrees. Would you solve that one, please? And then come back and check your work with me. Press pause now. So I think I said A was 11 and B was 20 degrees. So that should look like this for your way it looks. Of course, finding the other angle is just 90 degrees minus B. 90 degrees minus 20 degrees leaves 70 degrees for angle A. That was pretty easy. Not too hard to find the other things either. The tangent of angle B is B over A. So solving that for B, we just multiply both sides by A, and we see B is A times the tangent of B. A is 11, B is 20 degrees, So we can just type that into our calculator as 11 times the tangent of 20. Remember, I'm in degree mode, so I don't have to type the degree symbol. If I were in radian mode, I would need to type the degree symbol. And so you get a little bit bigger than 4.00367, etc. centimeters. I might need that later, so I'm going to store that as B. Okay. Now, how do I find C? Well, actually, now that I have B, I could use the Pythagorean Theorem to compute C, or I can just do it from what I have given. So I'm going to do it from what I have given here. So when I'm doing these videos, once you start to find some information, then that opens up multiple possibilities for how you can find some of the other information. I'm going to show you one way to do it. And then you could, for example, I could use the Pythagorean Theorem here as a check to make sure I did things right after I've actually computed it the way I'm doing here. So sometimes there are some built-in checks that you can make use of. So cosine of angle B is adjacent over hypotenuse, so that's A over C. Multiply both sides by C and divide by the cosine of angle B, and we get C is A over cosine of B. A is 11, B is 20 degrees. So that's 11 divided by the cosine of 20 degrees. And I'm going to go ahead and store that as C. And we get that. Now notice we could, what I was mentioning is a check. A was 11. So 11 squared plus B squared. That's A squared plus B squared. Now let's check out what C squared is. Should be the same thing as what we just came up with. So there's a check. So the Pythagorean Theorem could be used as a check if you want. So it's nice to have some built-in checks there. The area is A times B times 1/2. So we can take A times B and divide by 2. And there's your area, 22 square centimeters. Alright, come back for some more examples in the next video as we look at the next case.